Hello, welcome to Kira Cloud Hub. I hope you are all doing well. My name is Paulina Mwakira, and today we'll be continuing with our series of the Cloud Practitioner Bootcamp. Our focus on today's topic is the cloud closet. Where do we store our data in AWS? So it's been a good ride. The last videos were how do we perform compute within AWS cloud? What are the different compute services we have? Today our focus will be what are the different storage services we have in this case. Yep. So to get started, cloud closet. Where exactly do you store your data in AWS, and which storage solution will be the best for which use case? So our focus today will be on EBS, the Elastic Block Storage. Instant Store, we'll discuss what that is in a moment. EFS, the Elastic File System. S3, Simple Storage Service, and the data migration tools that we have available in the cloud. So just to get started, we have to understand the different cloud storage types that we have available. So the first storage type that we will be dealing with is block storage. And what is block storage basically? Now, imagine if we are filling our cabinet with drawers, and each drawer holds like a block of information. So we have a cabinet, it has its own drawers, and when you or an application needs to retrieve data, I have to go specifically to the exact drawer where that specific file is. That is how block storage is like. It's a dedicated, we call it low latency storage, that is directly attached to our servers. So it's a private high-speed connection to the storage device. Basically, the hard drives we use are examples of block storage. So if we look at examples, we have the Elastic Block Store, which we'll discuss. And for those who are familiar with the on-prem world, this is similar to the direct attached storage, DAS, or the storage area network, SAN. And in the cloud, we have block storage solutions like EBS that are provisioned with each virtual server and offer a very low latency required for high performance. So when do we use block storage? It's best for high performance workloads in this manner. So think about databases or ERP systems. Now, the next type of storage is file storage. So what differentiates between block storage and file storage? File storage is just like a shared file system. It's a shared office space. If it's a shared office space, everyone has access to the same files, cabinets, and file storage is designed for scenarios where multiple users or applications need access to the same file cabinets or a common shared space. So shared access to files. And for those who are familiar with also the on-prem networks and so on, this is similar to the network attached storage server that we see. And so NAS. And in the cloud, we have like file storage solutions like Amazon EFS, when you need to manage lots of files, media, home directories, any project files, and share these files across multiple systems, up to hundreds of servers or multiple applications. The other storage type we have is the object storage. And with the object storage, this is now just a digital archive. Any piece of data is stored as an object. That is why it's called object storage. And each object has its own unique identifier, and it also has its own unique metadata in this case. So very highly scalable, very flexible, perfect for storage large amounts of data, any large amounts of unstructured data, backups, archives, photos, videos, anything you can think of. So those are some of the things, and an example of object storage is the Amazon Simple Storage Service that we are going to discuss in a moment. Now let's explore some of the block storage solutions that we have available. And the first one we're going to talk about is the EBS Volume. Think as it as a network USB stick in this case. So it's a network drive that you attach to your EC2 instances to store data. and it offers like persistent storage. What does that mean? I attach it to my instance, and the best part of it is even if you shut down that instance or you terminate that instance, the data stays intact within the volume. Now at the cloud practitioner level, you can only mount one EBS volume to one instance at a time. So it can easily be detached from one instance and attached to another, and it's bound to a specific availability zone. So if we look at some of the key features that we get with the EBS volume, first things first is the network attached storage in this case. So it's not a physical storage, they are network based, meaning they are connected to our EC2 instance via the network. This can bring up just some small bit of latency in that manner. Now, EBS volumes are also locked into a specific availability zone. That means that if your instance is in UST1A or something like that, the EBS volume also has to be in that same availability zone. EBS volumes can be easily attached and detached and reattached to other instances however you wish. And now the other thing is, if you want to move an EBS volume from one availability zone to another, you first need to take like a snapshot of that EBS volume and then create a new volume in the target availability zone. Talking about the billing aspects, so EBS volumes are provisioned with a specific size in terms of gigabytes and IOPS, that is input-output operations per second. You get billed for the entire provisioned capacity, whether you are using it or not. And the other thing is you can increase the size of your EBS volume, and you don't need to worry about running out of storage as your needs in AWS grow. Now, just a continuation on EBS volume, some of the things you might want to know about. So we have these two features of EBS volume. The first one is the delete on termination attribute. This is an attribute that controls what happens to an EBS volume when an EC2 instance is terminated. Now, by default, the root EBS volume, which is the main storage attached to our server, is deleted when we terminate our instance. That is a behavior which is enabled by default. Now, you can change this behavior either using the console or using the CLI. So, if you want to preserve your root volume, or perhaps maybe retain your OS or your configuration, you just have to disable this delete on termination attribute, ensuring that it remains even when our instance is terminated. And I'll also show you this in the next video. I'll be doing a demo on all these topics. Another feature which I've talked about before is the EBS snapshots, and snapshots are like backups of our EBS volumes taken at a specific point in time. When you create a snapshot, it captures the state of your volume, which can be restored later when needed. So you do not actually need to detach the volume from an EC2 instance to take a snapshot, but it is generally recommended to do so for some consistency. Another cool feature about these snapshots or these backups is they can be copied across availability zones or regions, which can really help with disaster recovery and also data redundancy. So another type of EBS volume is the instance store. And what does the instance store help us with? We get direct access to a high performance hardware storage. This is now a hardware disk. The EBS, which said it's a network attached storage. Now, this means that we are going to get very good I/O performance compared to EBS volumes. So now EBS, we said we think about it as a USB stick. It can be attached and then removed, attached to another instance. Now, with the instance store, now think of it as a super fast hard drive that is directly plugged into your computer. And that means that you're getting high speed access, but does not offer the persistent nature we get as with EBS volumes. And that is why the concept of ephemeral storage comes in. This means that when we stop our instance or terminate our instance, our data is lost. So before this cloud thing on Microsoft Word came about, sometimes if you did not store your document, you're going to lose it. So it's the same thing over here. It's just like a scratch pad for your quick notes. So once you close your notebook or you stop the instance, everything is wiped clean. Now, some of the use cases of instance store, first, as we talked about, temporary storage or transient data, like buffers, caches, scratch data. So if you're doing like a big computation and you need temporary space for immediate results, an instance store will be perfect for you. Any temporary content that does not need to persist long term, maybe logs, maybe temporary files during processing, you are going to use the instance store. And one key drawback that comes with that is the risk of data loss if the underlying hardware fails. So additionally, things like backup, replication, that is your responsibility. So you need to have a strategy in place in order to ensure that your data is not lost in case of failure. And those are the two types of block volumes that we get with AWS. So the two types of storage that we can attach to our servers in that manner. Now, the next is the file storage. So we talked about file storage, and in AWS we have the Elastic File System. And with the Elastic File System, we get a managed network file storage that allows us to share data across multiple servers. And this makes it an ideal solution for workloads that need a shared file access. So it allows us to mount like the file system to hundreds of EC2 instances simultaneously. And as I mentioned before, it's just like a shared folder on your network. All the computers have access to this shared folder at the same time, no matter where they are working from. One thing to notice, EFS works for Linux EC2 instances. Please note that. So it's only for Linux. And also what differentiates it from EBS again is it can be available across multiple availability zones, and this ensures that your data is highly available and fault tolerant. So with EFS, you don't need to worry about capacity planning because it automatically scales the more you add data. So some of the advantages and considerations of using EFS. One, highly available, scalable. You can store as much data as you want and it will be accessible also across multiple instances. You don't have to worry about capacity. However, EFS is kind of more expensive compared to the other options like EBS and Instance Store. It's approximated to be like 3 times more expensive than just the general purpose SSD EBS volume we get. And we pay for what we use. So you only pay for the storage that you use in EFS. Now let's take a look at the comparison between EBS and EFS. And what you're going to note over here is how EBS is bound to a specific availability zone, and it can be attached to an instance only in the same availability zone. If we want to access an EBS volume from a different availability zone, we need to take a snapshot of it, backup of it, and restore that backup or create a volume from that snapshot in the second availability zone. But for EFS, it's really cool. You just have to create the mount targets in the different availability zones, and once the mount target is created, all the EC2 instances will have access to the shared file system. So if we had like that availability zone over here and it has instances, as long as it has a mount target, we will be able to connect to our file system. So EFS Infrequent Access is a cost optimized storage solution for files that are not accessed on a daily basis. And because we are not accessing them frequently, we are going to get some significant cost savings, like up to 92% lower cost compared to the standard storage class. So maybe you have like a cabinet for files that you don't need often. Instead of keeping everything on your desk, right? You can move those files to that storage and then you will have access to them as and when you need them. So EFS will automatically move files to the infrequent access storage class based on the last time they were accessed. So for example, if files haven't been accessed in like 60 days, they can be automatically moved to the infrequent access storage class. So how does it work? You're going to set up a lifecycle policy. And this is like defining what are the rules of how your files should be moved. And for example, you could configure a policy that says move files that haven't been accessed in the last 60 days. And the best part about this is transparent to your application. Your application won't know the files have been moved to a lower storage class. They'll just continue accessing them as usual. Okay. FSX for Windows File Server. Now, as I mentioned, EFS is for Linux systems. How about Windows servers in this case? So FSX delivers for Windows, delivers like a Windows native file system that allows for a shared file storage in a Windows-based environment, making sure that we have smooth integration with our existing infrastructure. So same like EFS, but now for Windows, based on the Windows file server, some of the key features compatible with the SMB protocol, which is actually the standard file sharing protocol for Windows systems. And it also supports Windows NTFS, which is used for managing file permissions and access control. It integrates seamlessly with the Microsoft Active Directory, and that means that you can simplify managing users' access and also managing your security policy. If your organization is using Active Directory to control access to resources, FSX for Windows File Server will integrate seamlessly with that and will work the same way, ensuring consistency across like your cloud and on-prem systems. We also have another flavor of FSX. So FSX for Lustre. And this one is for applications that demand a fast and scalable data access, such as applications in a scientific computing environment, AI model training, big data analytics. Use case for this, if you have like very large data sets that need to be processed quickly and efficiently. Imagine like processing video data for real-time streaming, or maybe you are analyzing large financial data sets in like a second. FSX for Lustre will make that possible. So it offers like extreme performance, scaling up to hundreds of gigabytes per second in terms of throughput, with millions input-output operations per second and very low latency of under 1 millisecond. So we are moving like from a regular car to a rocket in this case when it comes to speed and data handling. So if you're processing some data-intensive tasks, this is the kind of performance you need. So EFS, FSX, those are the file storage solutions that we have available. Now let's move to object storage solutions. S3. This is one of the foundational services in AWS, often considered the backbone of cloud storage. How would we advertise it? Infinitely scaling storage, meaning you can store large amounts of data and grow as needed. Now, it's just a very, giant digital warehouse. No matter what you store in it, there is always room for more in this case. So many websites actually rely on S3 to handle and store data, and a wide range of AWS services also integrate with it. Now, for the CCP exam, for those who are preparing for that, you'll need to go beyond just understanding what S3 is. You'll need a deeper knowledge of how it works, how to use it, what are its key features. So some of the use case, backup and storage, things like disaster recovery, archiving data. For hybrid cloud storage, application hosting, media hosting, and data lakes is a go-to choice. And also, if you want to just host static websites directly on S3, that is very possible and making it ideal for delivering web content with minimal setup. Now, if we look at an overview of Amazon S3, we normally store our data in buckets. So buckets are like containers or directories that you store your objects. And these objects can be anything ranging from text files, large media content in this case. Now, each bucket must actually have like a global unique name. No two buckets can have the same name across all AWS accounts and all regions. And even though Amazon S3 operates like on a global scale, the buckets are created within specific regions. So we have different naming conventions like no uppercase letters and underscores and so on. The name cannot be an IP, must start with a lowercase. So we have lots of constraints on how you name your bucket. So these naming conventions actually help us maintain uniformity and ensure that S3 buckets can be accessed correctly across like the whole world, the globe. Now, concept of objects. What is an object? Just think of it as a file. Any file you store in a bucket is an object. We call them objects. And objects are identified by an object key, which is essentially the full path to the file within that bucket. So S3 does not have like traditional directories. So instead, it uses like keys with slashes, how you see over here, to simulate folder structures. For instance, here, my bucket.s3.amazon.com, and then the maybe directory, which would be a prefix, and the name of that object. Here it was pub.jpg in this manner. Some of the key things to know: the maximum size of an object you can upload in S3 is 5 terabytes, so 5000 GB. But if you need to upload a file other than 5 GB, in this case, they recommend using multi-part upload. And multi-part upload is just like if you have a huge file to upload, you divide it into smaller chunks and then upload those chunks in parallel, which speeds up the process. Now, S3, objects in S3 have like their own metadata, data about data, which are just like key value pairs that provide additional information about the object, and so on. So now that we know S3, object storage solution, how do we set up security in Amazon S3? So we have different types: user-based access and resource-based access. So with user-based access, we're going to set up our IAM policies. And here we define which API calls a specific user is allowed to make. Like, for example, a user might be granted permission to upload objects but not delete those objects. So IAM policies, list of rules that determine which actions a person can take. And then we have the resource-based access or resource-based policies. And here we have different types. Bucket policies. These are used to set rules that apply to the entire bucket. And these policies can also allow access from different AWS accounts. We have like object and bucket access control list. Access control lists provide like finer grade control in this case. So you can set permissions at the object level for more specific permissions through ACLs. For example, the bucket is private, but this specific object, I want it to be publicly accessible. So we're going to use the access control list for that. So what makes it possible for you to access an object in S3? Your IAM permissions must allow that access. The bucket policy or bucket access control list, so the resource-based policy, must also allow that access. And if there is any deny anywhere, any explicit deny in any of the policies, your access is going to be denied. So by default, as you see in the diagram, a bucket is always private. Only the owner has access to it. Anyone else no. But we can make a bucket public, and when we make a bucket public, anyone can have access. Or we can use the policies, the access policies, for more fine-grained control in this case. So for example, the owner and specific users have access to the bucket while other users do not have. Now let's take a look at some the bucket policy structure in this case. So this is an example of a bucket policy, and our policies are defined in JSON. So we have resources, and resources define which buckets and objects the policy applies to. We have the effect, which will tell us the action. Is the action allowed or denied? And then we have the actions, which are API calls that are allowed or denied. Things like S3 get object, S3 put object, S3 list object, whatever you think about, any API call. And the principal refers to the user or account that the policy applies to, who can perform that action. So if we look at some of the use cases of the bucket policies, we want to make a bucket public. So granting public access to a bucket requires this policy. Maybe forcing encryption during upload. We want to make sure that every object that is stored in the bucket is encrypted. We can use the bucket policies to enforce this. And also cross-account access, where we're trying to grant access to another account. We can use the policies for this. Now, looking at some of the different permission policies that we have. So, for example, over here, if you want to enable public access to a bucket, we are going to utilize a bucket policy. If you want to give a specific user permissions to access S3, then the IAM permissions, we are going to edit their own permissions to give them access. And if we want to enable access, for example, for services to communicate with each other, maybe EC2 needs access to some objects in an S3 bucket, we are going to utilize IAM roles for that. And for any type of cross-account access, we can utilize our bucket policy for that. So we have these block public access settings that were designed to prevent any accidental data leaks. So this set of settings ensure that sensitive company data is not exposed to the public, keeping it private and secure. So you can configure these settings like at the account level, meaning they'll apply to all the buckets within that account. That is if you are certain that none of your buckets should ever be public. So it's best settings to keep these settings enabled, and these are the settings which actually make sure that all our buckets are always private by default when created. Another concept of S3 is versioning. Versioning is actually enabled at the bucket level, and once it's turned on, any file uploaded with the same name will be given a new version number. So think of versioning like saving multiple drafts of a document. Each time you make a change, a new draft is saved, and you can go back to the earlier draft when needed. Now, it's best practice to enable versioning for your bucket just to protect against accidental deletion of files. And if something gets deleted or overwritten, you can restore like a previous version of that file. And versioning also helps us like roll back to a prior version if we make a mistake, or maybe the previous file state is needed. If you have ever used like Google Docs, versioning works in a similar way. You can restore an earlier version of a document, making sure you don't lose any important information. So any file that was not versioned before enabling versioning will have like the version null. And also we can suspend versioning if we don't want to keep versioning our objects. But when we suspend versioning, the previous versions of our objects are not deleted and they stay in place. Another feature of S3 is replication. So we have different types of replication, cross-region and same region, just from the names itself. So cross-region replication and same region replication allows for keeping multiple copies of objects by copying one of objects from one bucket to another, either within the same region or different regions. So for this to be made possible, versioning must be enabled in both the source and the destination bucket. And this replication process is asynchronous, meaning that it takes some time to complete after an object is uploaded. Now, additionally, we have to configure our IAM permissions properly to ensure that S3 has the appropriate permissions to replicate objects between these two buckets. So some of the use cases, when we talk about cross-region replication, it's typically used for compliance, making sure that our data is replicated to a different region for redundancy or legal requirements. It also helps with like low latency access by placing copies of your data closer to your users in different regions. So cross-region replication is useful when replication is needed across AWS accounts. Same region replication, on the other hand, is ideal for scenarios with like log aggregation or live replication between the production and our test environments within the same region. So this setup allows for fast, efficient replication without leaving that specific region. Now, speaking of concepts on durability and availability of Amazon S3. So S3 offers extremely high durability. We call them 11 nines of durability. And this means that objects are stored across multiple availability zones to prevent against data loss. So durability, how much data can you lose? And in S3, if you like store 10 million objects in S3, you can expect on average to lose just one object every 10,000 years. And you can see how durable that is. Availability, on the other hand, we are referring to how often our service is accessible or up and running. So it's different from durability. And the percentage of availability depends on the specific storage class, which you are going to discuss in a moment. So availability is more like maybe opening hours of a store. If a store is like 99.99% available of the time, it's open for business almost all the time, but there is like a small window where it might be closed. And as I mentioned before, the availability kind of depends on the storage class that we choose. So we have the general purpose storage class. This is ideal for data that is frequently accessed, providing us 99.9% availability. And this kind of guarantees us very low latency and high throughput, meaning data can be retrieved very quickly and efficiently. So this is designed to be very resilient, able to handle two simultaneous facility failures without disruption because our data is copied across like 3 availability zones. Use cases: big data analytics. You require quick access to large data sets, as well as maybe mobile and gaming applications that require real-time data access. S3 standard is also a great fit for content distribution, where users need access to data quickly and reliably from various locations. The other type of storage class is standard infrequent access, designed for data that isn't accessed regularly, but needs to be retrieved quickly when required. So it's more cost effective compared to S3 standard due to the lower frequency of access. Now, this offers like 99.9% availability and makes it suitable for scenarios like disaster recovery or backup storage, where you don't need constant access but require like fast retrieval when disaster strikes. And then the other flavor is one zone infrequent access. Maybe from the term one zone, you already have a clue. Offers 11 nines of durability again, but stores data in only one availability zone. So it offers lower availability, like 99.5%, but it's a more affordable solution for secondary backups. So when do we use this? Useful for backup copies of maybe on-prem data or data that you can easily recreate if lost, as the risk is higher, or the risk of losing data is higher when stored within just one availability zone. Now, Glacier storage classes. We have the Glacier Instant Retrieval, perfect for archiving data that might be needed occasionally, maybe like once a quarter or something. Retrieval happens in milliseconds, so it's ideal for when you need quick access to data after a very long time. So it has a 90-day minimum storage solution, meaning you'll be billed for at least 90 days of storage, even if you retrieve data sooner. We have the Glacier Flexible Retrieval. And here we have multiple retrieval options. Expedited, where you get your data within 1 to 5 minutes. Standard, 3 to 5 hours. Bulk, 5 to 12 hours, which is free. So it's useful when you don't need immediate access but want some flexibility in retrieval times. Again, this class also has like a 90-day minimum storage solution. And then we have the most cost-effective Glacier Deep Archive for long-term data storage, but it comes with longer retrieval times. You have to wait a while before you get your data back. So we have like 12 hours for standard retrieval and 48 hours for bulk retrieval. So this is ideal for data that you might not need to access for several years, and it has like 180-day minimum storage duration. So Glacier Instant Retrieval, a file you might need access to it once every few months. Glacier Flexible Retrieval, maybe an old document you might need, but don't mind waiting for some minutes or some hours. Glacier Deep Archive, now this is a box of archived records. It's there when you need it, but you don't expect to pull anything out of it anytime soon. Now, the other storage class is intelligent tiering, whereby we have like a small monthly and monitoring fee. How it works, it will automatically move your objects between different access tiers based on how you're using or based on how frequently they are accessed. So this is done automatically for you. That is why they have to charge you something for monitoring how your objects are being accessed. So maybe, of course, we have the frequent access tier where our object will be placed first. If that object is not accessed for like 30 days, it's automatically moved to infrequent access tier. Maybe after 90 days, it's still not accessed, move to the archive instance access tier. And then you have some more configurations you can make. Maybe 90 days to 700 plus days, move to the archive access tier or deep archive access tier. But note that these tiers do not reflect the storage classes. These are just tiers for the intelligent tiering storage class. And now, apart from that, this is done automatically for S3 intelligent tiering. But you can manually set up your own lifecycle policies to transition objects. So this is manually set up by you. You have more options. You can set up deletion rules, expiration rules too. So for example, this is a custom rule. After 30 days, you want to move your object to a different storage class. Maybe after a year, you want to move it to Glacier Deep Archive. So lifecycle policies are manually set up by you. If we look at some of the cost factors of S3, what do you pay for? The storage type that you choose. We saw the different storage classes that we have. The number of requests and retrieval that you make to S3. Data transfer out of S3 you pay for. For some of the storage classes, like the intelligent tiering, there is a management fee associated with that. If you replicate your objects, of course, you incur more costs for replication and also versioning. And that is a high-level overview of S3, hopefully covering everything you need to know. Now, if we move on to some of the data migration tools that we have available, when you want to migrate data to the cloud, which tool should you choose? So you need to know the following information. Where are you moving data? For what use case? The types of data that you're moving, and if you have the network resources available. So AWS offers us a wide variety of services and also partner tools to help you migrate your data sets. And we are going to discuss the storage gateway, the DataSync, the transfer family, and the Snow family as part of the migration tools that we have available. Getting started with the storage gateway, we call it a bridge between your on-prem infrastructure and AWS cloud storage because it offers seamless integration to store data securely in the cloud while still maintaining local access for low latency needs. Some of the use cases of the storage gateway good for disaster recovery, allowing businesses to replicate and restore data from the cloud. It's also commonly employed for backup and restore, ensuring that data is stored off-site for safety, but still easily retrievable. And then additionally, it serves like as an on-prem cache, allowing for low latency file access by caching frequently accessed data locally. So we have different types of the storage gateway, and we are going to start with like the file gateway. So the file gateway, we access using the NFS and SMB protocols, and this caches recently used data, supports S3, standard, infrequent access, all the like majority of the S3 storage classes. So you can also transition to S3 Glacier for lifecycle policies. So native file access to Amazon S3. FSX file gateway gives us native access to Amazon FSX for Windows file server. So it's Windows compatible, supporting the SMB, NTFS, and also the Active Directory. And it can also perform a local cache for frequently accessed data. So this is useful for group file shares and also some home directories. We have the tape gateway. It's a VTL, the virtual tape library backed by Amazon S3 and Glacier. And it supports existing tape-based processes and kind of works with leading backup software vendors. And then we have the volume gateway, which enables that block storage using the ICIC protocol. I'll put that using the ICIC protocol. So this is backed by EBS snapshot, so it's used for block level backup. So we are thinking EBS volumes. It can also cache our volumes for low latency, and also it also has stored volumes for on-prem data. Okay, next we have the DataSync. DataSync allows us to move large amounts of data between different environments, whether it's on-prem to AWS, other cloud platforms to AWS, or just between AWS services. So when transferring data from on-prem or other clouds to AWS, an agent is required. And when replicating data between AWS services, we don't require an agent. And this makes it easier to move data within AWS infrastructure. So DataSync can synchronize data to various AWS storage services, including S3, EFS, FSX, and you can schedule some replication tasks based on your needs. So maybe whether it's hourly, daily, weekly, to keep your data synchronized. So importantly, our file permissions and metadata are preserved during the transfer, ensuring that your data remains consistent and secure. So like a single data sync agent can handle up to 10 gigabytes per second of data transfer, and you can set up like bandwidth limits if needed to manage network resources more efficiently. Now, those are some of the online migration transfer tools. Now, let's go to the offline ones. Now, I got these estimates from Stefan Marik's course on Udemy. Like, if you have 10 terabytes of data and you need to transfer to the cloud, if you have like 100 megabytes per second, it will take you 12 days. If you have like a network connection of 1 gigabyte per second, it will take 30 hours. And 10 GBs per second takes like 3 hours. And honestly, I don't think I have used even 10 gigabytes per second network. So you realize how long it will take to transfer this data. If you have 1 petabyte and you're using 100 Mbps, it will take you 3 hours to transfer that data. So there are some challenges that we face. Maybe you have limited connectivity and bandwidth, or very high network costs, or shared bandwidth issues, or connection stability concerns. So we might need a physical or offsite data transfer solution. And for this, so we have the Snowball Edge, and this is a physical data transport solution, as you can see on the diagram over there, designed to help you move terabytes or petabytes of data into and out of AWS. How do we do this? By bypassing the cost of transferring. No. So we have the AWS Snowball Edge, which is a physical data transfer solution designed to help us move terabytes or petabytes of data in and out of AWS, bypassing the costs of transferring large volumes over the network. So you pay per data transfer job, and the Snowball Edge provides like block storage and S3 compatible object storage. We have two versions of like the Snowball Edge. The storage optimized, giving us up to 80 terabytes of HDD capacity for our block volumes, and S3 compatible object storage. And we also have the compute optimized version, which offers us up to 42 terabytes of HDD capacity. And this one is suitable for workloads requiring both storage and compute capabilities. Common use cases of the Snowball Edge include large-scale cloud migrations. Maybe you are doing a data center decommissioning and disaster recovery, providing us with a very fast and secure way to transfer your data without overwhelming your network. Now, the other device is the Snowcone, which is a compact, rugged device that offers edge computing capabilities, storage, and also data transfer. So it weighs just 4.5 pounds and provides like 8 terabytes of usable storage, making it a portable solution for remote locations or environments with like limited space. So Snowcone, it's perfect for situations where maybe our Snowball device might not fit, especially in space constrained environments. It's designed to be like secure, durable, and it requires like external power, like batteries and cables, and can be sent back to AWS offline or connected to the internet using DataSync for seamless transfer. Now, lastly, I'll just do an overview of AWS Backup, which is a fully managed service designed to automate and centralize backups across multiple AWS services. And this kind of saves you from creating the custom scripts or manual backup processes. So it supports a wide range of AWS services, the likes of EC2 EBS, RDS, S3 EFS, as well as all the other databases, Aurora, DynamoDB, and so on. If we look at some of the features of the AWS backup, it allows cross-account backups and cross-region backups, and offers features like point-in-time recovery for certain services. So backup operations can be on demand or scheduled, and you can define your backup frequency and retention periods, with also options to transition your backups to cold storage for like cost savings. So you can manage your backup policies through some backup plans, which are easy to configure and enforce using some tag-based policies. If you look at an overview of how DataSync works, of how AWS backup works. So you create a backup plan, which will include your schedule, your life cycle, the vault, and the tags for the backups. Assign the resources that you need to backup, and then just AWS backup will automatically run the backup plan you have specified, and you can centrally monitor your backup activity. And that is storage in AWS at a high level overview. So in the next part 2 of this, I'll just be doing a demo on some of the concepts we have discussed, so look out for that. Thank you, and you can follow me on LinkedIn at Paulina Mwakira. Bye bye.